Hi, this is Craig Stocks here at Utah Desert Remote Observatories. You can find us online at utahdesertremote.com. And today I want to talk about this image that I posted earlier today. And it generated some questions because of the way I handled the, this is a simple HOO image, and there was hydrogen and oxygen. But I created an artificial third channel by subtracting the oxygen from the hydrogen. And I'm going to walk through how I did that in Photoshop. Even though this was done in Photoshop, I want to start in Pix Insight because that's really where everything for me starts. So let's just quickly walk through what I did in Pix Insight. So let me open this up. I've already run it through WBPP, just pretty standard. I've got other videos that show the WBPP setup, so I'm going to skip over that. And I'm going to jump straight to opening some of the files. And I keep all of my swap files on my D drive in a PI swap files folder, and then as the D drive fills up I just delete these, and so it's pretty much just a throwaway. And this is, so we go to Masters, and we want red, green, and blue to start with because we want RGB stars. And just very quickly, what I do for the RGB stars is I don't think anything very special. Open those three, and these were at 2-minute exposures because I was really focusing just on getting data for RGB stars. So start with channel combination, red into the red channel, green into the green channel, blue into the blue channel, and then the solid circle to execute that. And once that's executed, we're done with the channel combination window, and we're actually done with the individual red, green, and blue. And I've been experimenting with using Grabert versus the dynamic background extraction. Sometimes I like the way it works, sometimes I don't. It kind of depends on the image. On this one, I don't know that it worked all that well. I don't like to crop my images before I'm completely done with them. And Grabert sometimes has some real problems with edge artifacts. We'll try it here real quick just to see what it looks like. But if there's edge artifacts where things don't line up, it just seems to throw it off, and you wind up with some really nasty shadows and edge artifacts. And I would say in general it's probably a little bit more aggressive than I would want it to be. Sometimes, like I say, sometimes it's okay, sometimes it's a little too much. It's okay here. Change the color quite a bit, but the next thing I would do is, and we're not going to take the time to do it, but I would run Blur Exterminator for correct, and then run spectrophotometric color calibration, and then Blur Exterminator for the nebula. And then lastly I would do a screen transfer function, usually modified a little bit, and then apply that with the histogram transform to actually stretch the image. And then lastly run Noise Exterminator and Star Exterminator. And when that's done, the things that are really worth saving out of that are primarily the stars, and sometimes I'll use the RGB data, and we'll just take a quick look at those to see what they look like. So there's the stars in the background. Make sure these are the right ones. Those are the right two. Today's the 13th. So we'll just open these real quick to see what they look like. So there's the RGB and there's the stars. And I usually add a little bit of saturation at this point because the image is still pretty malleable before I save it as a 16-bit TIFF. And I find when I put the stars on top of a saturated background, you tend to lose the saturation in the stars. So that's just very quickly how I created the RGB stars. And then for the HOO, it's pretty much standard HOO processing. Again, I'll go back to the swap file. Look in the masters folder, and we'll have a hydrogen and an oxygen. And I don't really need the luminance for anything, so we'll just take the hydrogen. Oh, those are flats, hang on. Let's get the right files. Let's get the right folder, then we'll get the right files. There we go. Now we've got the right folder. There's the oxygen and the hydrogen that were created earlier today. Sorry for all that wandering about. And I'm going to process these, pretty much the same way I would process any narrowband data. And there's about a half dozen. I think there's 6 HA and 4 O3, something like that. So it's about an hour and a half worth of total narrowband data. There is the oxygen, and there is the hydrogen, and my process is pretty standard. I didn't run any dynamic background extraction or Grabert on this. I just did a blur exterminator and then star exterminator and noise exterminator to create the starless monochrome images, and then I also saved those as 16-bit TIFFs. So the end result, which we'll see when we go into Photoshop, is these saved as starless stretched 16-bit TIFFs and the RGB stars. So let's get on with it in Photoshop. And if you've watched any of my videos before, you know we start with File, Scripts, Load Files into Stack. And we use this to load the individual folders or individual files as layers. And so we'll go to our Astro folder, to the Dreamscope data, the Rosette, and we want the oxygen, hydrogen, and the stars. And those are really the only ones we're going to use, so we'll just keep it simple. Click OK, and you'll see each one of those files now loads as an individual layer. There's the starless hydrogen, starless oxygen, and the stars wound up at the bottom. Just some very quick housekeeping. I'll drop this into a group, change the group name to oxygen, and I know I'm going to use a levels adjustment layer, so we'll just throw one in and do a little bit of preliminary adjustment here to add a little bit more contrast. And then do the same thing with the hydrogen. Drop in a levels. Darken the darks and whiten the whites. And notice I'm coming up to kind of just close to the edge of the histogram. So I'm using the full range of tones, but not blocking up the blacks or blowing out the highlights. And then the stars. Again, we'll drop those into a group. Change the name to stars. Again, a levels, and this time a hue saturation. Most of the time I wind up adding a little saturation in total, and then the reds tend to get too saturated, so I pull the red saturation way back. And we'll put this in screen blending mode and move it to the top of the stack. So now we're ready to create our HOO image. So let's turn on the hydrogen. I'll turn off the stars for now. There's the oxygen. And if you've seen me before, you know the way to make this an HOO image is simply to double click here to the right of the group name. And because this is actually an RGB image, even though it looks grayscale. We have red, green, and blue channels. Just turn off the red channel, and there's an HOO image. But we want to make this a fabricated SHO image. And so to do that, I'm going to just quickly make a copy. I'll start with make a copy of the oxygen, and I'm going to drag it down to the bottom, drop it into a group, and label it fake S2. And then let's also grab our hydrogen. I'm going to make a copy of it, drag it down below the oxygen in that same group. So those are both in the bottom group. So now I've just made a copy of the hydrogen and oxygen. And we want this to become our red channel for an SHO type image. And to get to that, what I'm going to do is subtract the oxygen from the hydrogen. And the easiest way to do that, and the non-destructive way to do that, is just to change the layer blending mode from normal to subtract. And when I do that, you can see some data starting to show up. We probably will need to brighten this up a little bit. So I'm just going to add a quick levels. And let's do something. We'll start with something like that. And keep in mind, this is what's going to become red. If we think we're subtracting too much, we can adjust what we're subtracting by putting another levels adjustment here. But I want this one to affect only the oxygen. So I'm going to create what's called a clipping mask. And I'll do that with this clipping icon under the properties panel. So now any changes to this levels adjustment layer will affect only this oxygen layer. So now I can brighten or darken specifically just the oxygen that we're subtracting from the hydrogen, which is what's going to create our reds. So now we'll turn on the oxygen, and I generally like to put these with oxygen next. So if you recall, we've got both the green and blue layers turned on and the red turned off. That's why the only thing that's coming through from this bottom layer now is red. And if we want to change the color of that a little bit, I'll come into this oxygen group, I'll add a curves adjustment layer and put it in color blending mode so that we don't change the brightness, only the color. And then I'll grab the green, and using the far right hand, the brightness point of green, I can pull it down and change the overall color of this cyan to make it a little bit more blue. And then lastly, we'll turn on our hydrogen layer. And if you recall, we still have all three channels turned on here. I'm going to put this in screen blending mode. And immediately that gets too bright. So we'll use this levels adjustment and we'll tone it down a little bit. And now we want to add some contrasting color. And to do that, again, we'll add a curves adjustment. And again, we'll put this in color blending mode. And generally when I do what I call a natural SHO, the first thing I'll do is grab the blue curve and just drag the right-hand side down quite a ways. And immediately you can start to see some green and yellow coming through. Then you'll change either the red or the green, depending on which looks better. And in this case, probably reducing the red to bring even more green and yellow through. And with that, we can probably brighten this back up a little bit and get a little bit more color contrast. And let's come back to our red and brighten it up a little bit more. Get a little bit more red in the perimeter. Something like that. And then we might come back to our oxygen and adjust this green again to fine-tune the color of the oxygen. So at this point, that's a pretty good color balance. It's still pretty flat, but I would now just close those and start adding global adjustments with typically a levels, color balance, a hue saturation. And then the last layer I'll add is a solid color layer. And I want this to be 1919 RGB, which happens to be the same as 131313 in hex, which is the default data entry window. So just type 131313, OK, and then put this in lighten blending mode. And what this does is ensure that there's no pixels in this image that are darker than 191919. So we can add a little bit of overall contrast here by brightening the brights and darkening the darks. We might come into the hue saturation and address the blues and maybe reduce the saturation of the blues a little bit. And we can even drag this into the cyans, something like that. We might want to increase the saturation of the yellows, again trying to get color contrast. And at that point, this is becoming, a pretty finished image. I'm seeing a little bit of blue in the dark area, so I might come back to the hydrogen, and by darkening the blacks, since that's where the blues are coming from, that neutralizes those black areas or those dark areas just a little bit. Let's add a little bit more of the red from the fake sulfur. And turn the stars on, and there's a pretty finished image. At this point I would save it, open it up in Lightroom, do any final edits, color corrections. Probably would continue playing with this blue cyan color to try to optimize that, and then export it as a JPEG. In this case, the stars are pretty good. I don't know that we need to reduce them a lot. If we want to, we can always go to the stars layer. And to reduce the stars, we'll do two things. First, we'll just darken them. And that by itself, I think, is all we really need to do. The stars are already pretty tight here. And we're adding a good amount of saturation. You can especially see it in this yellow star over on the left-hand side. The last thing we might want to do is add some sharpening, and I like to sharpen each layer individually. I'll start with my fake sulfur, which is really these three layers at the bottom. The bottom layer of hydrogen, the oxygen that we're subtracting, and then the clipped levels adjustment. So I'll right-click and turn those three into a smart object. And once it's converted to a smart object, I can go to Sharpen, Smart Sharpen, and sharpen that layer a little bit. And then I would do the same thing to the oxygen and hydrogen pixel-bearing layers to sharpen those. In this case, it's just the individual layer. So again, convert to a smart object. And depending on what you right-click on, that option may appear in different places. Sharpen, Smart Sharpen. So now we're sharpening just the oxygen layer. And by having these on smart objects, we can come back and fine-tune the sharpening after the fact on each one of the elements. If one of the elements looks like it needs more or less sharpening. Again, convert to smart object. And filter, sharpen, smart sharpen. And that's basically all there is to it. It's an HOO image, and we created that third color to create more color contrast by, in this case, subtracting the oxygen from the hydrogen, and that created areas of green and yellow and gave us a lot more color depth and color contrast. So I hope you found this useful. If you have any questions, be sure to drop them in the comments below and I'll try to address them. If you're interested in hosting your telescope at Utah Desert Remote Observatories, we'd love to talk to you. You can find the contact information on our website at utahdesertremote.com. And I would remind you we also have hourly rentals if you want to rent some time on one of our scopes to collect your own data. Same way, you can get in touch with us there. So with that, I hope you have a great day today and an even better night tonight under a clear, dark sky. Thanks.